Hey everyone, my name is Alan Vasquez. I'm a senior at High Point University. So I'm from Greensboro, North Carolina, and actually have the pleasure of introducing the next speaker, Dr. Brad Barlow. So him and I go back since my freshman year. I've actually been lucky enough to do research with him for the past 4 years in astronomy. So through that, I've actually been able to go down to Chile twice on research trips funded by the university. And we actually discovered a star on one of those trips, which is amazing. And that really couldn't happen without an amazing mentor and somebody who's there to lead you through the way. And as Dr. Tarr said, not only be all the way up here, but be here in the pits with you doing all this work. And so really, after the past 4 years, it's my honor to introduce Dr. Brad Barlow, your next speaker.
It's a cold, dark night on Cerro Tololo in the Andes Mountains in Chile, one of the premier observing sites in the world for astrophysics. I, along with 2 other astronomers, are fighting exhaustion, busily using the telescope on the left to observe the night sky. Out of nowhere, we get an email from one of my collaborators who has detected a potentially interesting object, but doesn't have the capability to follow up on it. As such, we immediately drop what we're doing, slew this 2-ton behemoth of a telescope to the coordinates provided, and for several hours, we take one image after another of that part of the night sky. And what we find is striking. In every single image, the brightness of that star changes. A pulsating star, if you will. For the 20 minutes or so before we emailed my collaborator back, the 3 of us in that room were potentially the only 3 beings in the entire universe who possessed this particular piece of information. What I left out of that true story is a description of those 2 astronomers. See, they did not have their PhDs. They didn't have their master's degrees. They did not even have a bachelor's degree. They were 2 High Point University undergraduate physics majors. Alan on the right and Eugene on the left. I was their research advisor or mentor through this process. Even though I myself was told as an undergraduate, this sort of work was best left for the big dogs, the professionals, those with doctorates, they did everything. They opened the dome at dusk, they slewed this 2-ton telescope to the coordinates, they obtained data, they even wrote code to analyze the data, and now they're co-authors on a peer-reviewed publication in a scientific journal. That's not supposed to happen to undergraduates. Why? Society paints for us this very rigid image of what mentorship is. There's a clear mentor and mentee, someone who knows something and someone who doesn't, someone who teaches and someone who learns. There is a Plato to every Aristotle, a Barbara Walters to every Oprah. Of course, Harry had Dumbledore, and Lil Wayne had Drake as his mentee. But is this model the best model? Is this the way to be the most productive in terms of innovation? In our Department of Physics here at High Point, I think we've had the success we have had working with students because we reject this notion. Does there have to be a clear someone who knows something and someone who doesn't? Or are there just relationships? Do you both learn from one another along the way? 5 years ago, NASA put out a call for proposals to students to design, construct, and test simple devices astronauts could use to chip off samples of an asteroid in space. 5 of our students approached me and a different faculty member about acting as the research advisor, to which we said, heck yeah. For 2 weeks afterwards, we wrote a proposal, submitted it to NASA, and forgot about it. Why? To be frank, we didn't think we had a chance of winning that proposal. Of course, 1 month later, 2 of these students with smiles on their faces and pride on their shoulders knock on my door and say, Dr. Barlow, we got this proposal awarded. Any normal person at that point would have said, congratulations, I'm really proud of you. I said, oh crap. Oh crap, we have to build this thing. Oh crap, we don't know how to do this. But for the next couple of months anyway, we designed prototype parts in CAD. We printed them out in the machine shop. We stayed up until 4, 5, 6 in the morning designing additional pieces, testing the device. And literally 1 day before we had to go to NASA's Johnson Space Center in Houston, we completed the prototype. It was first tested in the swimming pool of a Holiday Inn in Houston. NASA gave us their neutral buoyancy lab, the world's largest swimming pool, if you will, which mimics a microgravity environment to test this thing in. And to our joy, it worked nearly perfectly. It chipped off samples of that asteroid simulant. My relationship and the other faculty members' relationship after this project with those 5 students was fundamentally different. Why? They learned that they could trust us. They learned that we weren't afraid to get in the trenches with them. They saw us stay up until 4, 5, 6 in the morning with them. They saw our hands literally bleed next to theirs, machining parts. Through this process, beginning a mentorship relationship with them, we put ourselves out on the line, and they learned to trust us afterwards. Of course, trust must go both ways with any mentorship relationship. I and my astrophysics research group here at High Point, I don't view my students as students. At least I try not to. I don't view them as undergraduates. I don't view them as people who are 10 to 15 years younger than I am. I honestly view them as my collaborators, as fellow scientists, as people I can rely on to do science with me and my group. Once per year, I take a few of these students down to Cerro Tololo in Chile, the mountain I opened up with. And while there, I give to them all responsibilities I would give to my collaborators who have PhDs in Germany. They move the telescope, they collect data, they write code, we write papers together. And why is this important? I want them to have the chance to move a $10 million piece of equipment. I want them to have the fear of breaking a $10 million piece of equipment. And I want them to have the joy of having successfully moved a $10 million piece of equipment, something undergraduates aren't supposed to do because of this rigid idea of mentorship. That's best left for the big dogs. But maybe that's not the best way to operate. Another side effect of this, of course, is along the way they gain confidence. We take these students to international conferences. The last one I went to was in Krakow, Poland. All 3 of my students who went with me gave presentations. A collaborator of mine I've known for 10 years, after the fact, congratulated me on the fine success of my graduate program here at High Point University. We don't have a graduate program. You give them a task, and they will always meet whatever bar you give them if you approach mentorship in the right way. I think the last reason we've been successful in our Department of Physics is because of having a particular mindset on the mentor's side. We always talk about how to help the mentee. What about the mentor, the person who is in power, so to speak, there? Any newly minted PhD probably exits the hall of a graduate program, arms extended, medieval garb shining in the sunlight, and approaches the world as follows. I have a PhD, I can do anything. I know you don't. I can't learn anything from you who are beneath me. We all have that tendency anytime we have a position of power. This is the academic version of that. On the left is an image of one of our students, Thomas Boudreau. By any metric, he truly is an extraordinary student. He first went observing with me at a professional telescope as a high school senior. He has written his first author peer-reviewed paper in a scientific journal as a sophomore. And last year, he received honorable mention for the Goldwater Scholarship Program. Thomas enjoys working with neural networks. The idea that you can write a computer code that mimics how the human brain works to solve complicated problems. That is not my area of expertise. I don't know much about neural networks. A year ago, he approached me about advising him on such a research project. How easy would it have been for me to say no? My emotional response was, I'm scared. What if he surpasses me? I'm supposed to be the one in charge here, the mentor. What if he ends up knowing more than I do? That's opposite of Drake and Lil Wayne. But then I realized maybe our relationship in terms of research mentorship has changed so much, the mentorship itself must evolve. What if it's okay for him to get past me at a certain level, at a certain thing? Here's how I liken it. My astrophysics research group is an orchestra. Our job is to produce beautiful music, have scientific output. The players in the orchestra are the students in the group. They each play an instrument. I am the conductor, only because I have more experience. I can guide the bigger picture, but guess what? I don't have to play the violin as well as Thomas to still help him play the violin better himself. The conductor doesn't know how to play each instrument as well as the musicians, but he or she guides the music that's being played. Thomas is the first violin in this orchestra. I have learned so much from him about neural networking, and he has from me, but from a big picture standpoint. So the mentorship in some levels has evolved or flipped there, if you think about it in the traditional way, and that's okay. My story now comes full circle back to Alan and his new pulsating star. 1 month ago, a collaborator friend of mine sent us a light curve obtained by NASA in response to Alan's discovery of the very pulsating star he discovered. That light curve or data set was obtained with the famous Kepler satellite, literally located millions of miles away from the Earth. Such a data set, while pristine in quality, is notoriously difficult to work with. You have to write new code from scratch to analyze the data. Alan was given the opportunity to lead the follow-up study of this new data set from NASA's Kepler satellite. He could have said, oh crap. I could have said, oh crap. But he didn't, because our relationship in terms of research mentorship has evolved so much, we said yes. And through the process of analyzing this data set, I will be guaranteed to learn something from him, and he will learn something from me, and the scientific outcome will be all the better for it. What does all of this have to do with leadership? We all think that you should lead from ahead, and that's the case probably at the beginning of any mentorship relationship. Sometimes maybe you should lead beside them, thinking of them as your peers and collaborators, and sometimes maybe you lead from behind. And all of that's okay, especially when it comes to productivity. In terms of values, it's easy not to have a growth mindset. Again, the example being the PhD who thinks he or she knows everything. Maybe you can approach something, being open to learning from somebody beneath you, so to speak. And also treating others as your collaborators is very useful in many cases. I encourage every single one of you here today to find the collaborator in your mentee, to approach mentoring as something you don't only do for someone else, but as something you do for yourselves. And by doing so, you will find, most likely, more innovative solutions to the problems of the world you're trying to solve. Thank you.